Hi, welcome. My name's Simon Anderson, and I'm going to be giving the talk today on the journey from mGear to ueGear, Pythonic Postmortem. Before we begin, a little bit about myself. So I've been in the industry for just under 20 years. I often get called so young, but no, I'm not that young. During that time, I worked mainly as a character TD and a pipeline engineer. But I usually like a good challenge, so I kind of moved all around pipelines in film, in game, in TV commercials. I worked for big software engineering companies doing cognitive AI. And recently, I work for mGear, which is why I'm doing the talk today, and another company called Zuru. And we do kids' TV stuff right there in the front. Yeah, so a bit of a disclaimer for today. I'm going to be talking about Python, mainly focused around setting up a pipeline and talking about our experience with ueGear. This is basically going to outline a lot of code that is currently in flux. So the code might change, and everything that we're going to do is online at the moment, and you can get the source code. So we just want to have a little disclaimer that what you see here could change. So don't shout at me or send me Twitter messages of, oh, this is wrong. Hopefully it won't change, but it might. So today, a little table of contents, introduction done. We're going to have a little talk about the history of mGear, what mGear is, because some people, when I first started talking to everyone, they were like, what is mGear? So I quickly updated my slides yesterday to actually say what mGear is. Then it's going to go about the journey into Unreal, actually utilizing Python in Unreal, talk about FBX, the process from Maya, getting your data in, getting your data out, and then and then remote control and sequencer. So why give this talk? Over the last few years, I've been in managerial positions and often interviewing people for character TD roles or pipeline roles. You sit down and you're like, so have you ever worked in Unreal? Because that's one of the areas that we do. And most TDs will say, no, I've never done Unreal. I don't know C++. And after having quite a few conversations like that, I chatted to the guys at Epic, and I got to do this talk, and I really want to promote Python because you can do nearly everything in Python. And if you can't do it in Python, then the learning curve to enable it into C++ is quite small. And then usually what happens is that you start to do more C++ and more C++, and then you end up not doing any Python anymore. So this is the transition to the dark side. So yeah, like I had mentioned, what we're going to be talking about is just a little bit of history, some of the lessons learned, and then mainly interacting with Unreal. So what is Gear? Gear, or mGear, it's a modular data-centric rigging solution. So that's quite big words. I'll break it down. Modular rigging, basically, it's kind of like 5.4 in Unreal, but this is for Maya. So we have modules, arms, legs, spine, head, neck, and basically what it allows us to do is to create rigs really, really fast. So on a big production, it allows you to speed up your rigging processes so you can iterate faster, and you can get that data faster to the animators and get feedback and iterate. Data-centric rigging, on the other hand, is where we really start to leverage our rigging pipeline and the pipeline as a whole. Because most rigging solutions right now do not do data-centric rigging. So you'll make your rig, you might have a guide, cool, you update the geometry, then you have to re-rig, that's what it is. Data-centric rigging allows you to store and serialize all your data, your shapes, your rigging controls, so you can make them on the rig, on the guide, on the control, and it'll serialize that. It allows you to serialize your shapes, the rig itself, and then with one click of the button, it'll rebuild everything. So the benefit of that is models have changed. That happens in productions. The topology has changed. That also happens. You can bring it all in, hit a button, 10 seconds later, boom, same rig, updated, animators can go, new version out. And then on the very far right-hand side, that's part of the latest updates that we've got. That's called our shifter. There's a demo coming up. I'll show a bit more of that. It's quite quick. But What that is that in Maya now, we wrote a tool that you can take a mGear rig, or you can take a non-mGear rig, as long as you have a skeleton that is hierarchical, and you have geometry all under one node. And you can export geometry groups, so you can have one Maya scene file that has your one character with 10 different heads, 7 different weapons, and you can create groups in Maya in this UI, hit a button, and in one go it'll export all that data as individual assets using the same skeleton into Unreal. So it's really nice and fast. And the same thing can be happened with animation. So what you can do is you can have one where you're having a scene file or a shot, or you have one Maya file that has multiple different animation cycles in it. You can specify your timeframes, and then you hit a button, and basically we will split up your shot, export all the animations into Unreal, and automatically apply it to the skeleton that's in Unreal. Or you can generate the skeleton on the fly. We'll cover all that, and I'll show you the code. And one thing to be aware of is that all the code I'm talking about now is free. Open source, it's free. ueGear is free, mGear is free. We're under MIT license, so you can go in there and you can pick what you like. You can use everything, or you can use nothing. You just, I like that function, great. I'm going to talk through a whole bunch of functions, the nitty-gritty of the code, but it's all there, so if you like something, go and grab it. So, history of mGear. mGear, or Gear when it was started by Jeremy Passerin. I probably destroyed his name now. That's all right, there we go. So he originally started Gear many, many years ago in the days of Softimage. And Softimage was around quite a while, and this rigging solution started to grow. At some point, Softimage got bought out by Autodesk, and I think all the Softimage users were like, the writing is on the wall. We have to make a decision and hop to something else. And most people went to Maya. And at that time, I think he also saw the writing, and he started to implement mGear, which is basically Maya Gear. And then that got picked up by Miguel Campos. And Miguel Campos has been the #1 developer, or main developer of it, for the last, maybe 10 plus years. And he's really run with it and made it into a mature product. Because of him, I'm here today, turning to you guys. And he's driving mGear and ueGear and any other gear that is currently in creation that we haven't mentioned to the future. But I can't just mention them, because mGear was created by a community. I myself am just one of many who helped over the years. And like I was saying, it's all open source. So if you do want to add something, or you see something you don't like, you're more than welcome to hop on, join us on GitHub, and just become an addition. So, ueGear. When we set out our journey on ueGear, these were the things that we wanted to achieve. We wanted to streamline the Maya to Unreal interactions. We wanted to round-trip data from Maya to Unreal, and also from Unreal back to Maya, because if you're in a linear production, it's very iterative. We wanted to export skeletons and animation from Maya and make that whole process easier. We wanted to sync shot data so that if you're doing linear content, you can basically import shots specifically. And then we wanted to actually do the proper gear solution, which was exporting mGear rigs into ueGear so that you can do one-to-one relationship. So what will happen is that you'll have your mGear rig in Maya, click a button, and you'll have your mGear rig in Unreal. That is currently in progress at the moment, so all the red is what we have, or we're currently working on. We were trying to get that done for Seattle this year, so we can demo it there. So this is just a quick little fast-forwarded demo. This is Unreal, selecting some assets. This is the Maya interface. We click one button. It basically pulls the data from the Unreal level directly into Maya. We have a camera on this level sequencer. We just select the camera. You go to Maya. You hit import. Boom. Basically, the level... the camera will be imported into the level. It'll match up perfectly. We do all the matrix translations from the different left-hand to right-hand space. We also detect the frame rate. So that little message that appeared was the frame rate saying, like, the Maya frame rate was different to our Unreal frame rate, and we updated it. this is us just updating the data, our assets and camera in Maya. We select the asset we want. So this is the camera. We hit a button, basically go into updated the camera. And then we select the asset, we hit a button, and it updates the asset in the level. So it's all seamless, and all this is available in our main branch right now. Free, go ahead, get it. It'll turn your production time very super fast, because it's no longer export it here. What was the name? Oh, we're doing layout. Somebody moved something in Unreal. Now we have to update that in the actual animation scene. This will help you. So this is now the demo of our shifter tool. So that's an mGear rig, fully built. Shifter tool, you select the geometry, you select the roots of the skeleton. Then we just select, if we wanted to, we could select the directory where we're going to export it to and the name that we're going to export it as. But we're not doing that this go. This go, we're basically selecting at a folder in Unreal. You select it, you hit a button, it selects the folder in Unreal. Then we've done a geometry export here. So one click. What you're seeing is a batch process, because you can have multiple geometry groups. So you can batch out like 20 different versions of an asset all at once. Automatically imports it into Unreal. So this is me showing the geometry groups there. We automatically query Unreal. It brings in all the skeletons that are available. So you can select the skeleton that already exists in Unreal and import the animation onto a skeleton that exists, which is what I just showed there. And all this is currently available. So it's there, go use it. It'll make your turnaround times and iteration times much faster. Because we really see the writing on the wall and really want everyone to kind of, hey, this is Maya, but look at Unreal. Come on, you want to use it. So this talk is not just about me selling a product, me selling, hey, this is mGear. I really wanted to talk about Python. So how to use Python, getting it started, and then show you kind of like the nitty-gritty of how to do all of that. So where to start when you're starting at the beginning? Often you join a studio and everything is set up, and you can only need to do 1 or 2 minor adjustments as you go, add some code here to an existing repo. That's great. But most of the time, you don't have a blank canvas. So, you need to figure out all the processes. And this is kind of the lessons learned that we did as we were going through. So with mGear and ueGear, we're doing everything on GitHub. So we chose Git because our plugin sits outside of Unreal. And we also want the GitHub community so people can interact with it. So once you have chosen your source control of some sort, time to enable Python in Unreal. So this is quite really simple. You go to your plugins, you just enable the Python scripting editor plugin. While you're there, also enable the sequencer scripting. The reason why I say do both, because most likely you'll forget the one and then you'll be like me and you'll spend like half an hour to an hour pulling your hair out being like, why can I not interact with sequencer? What in the world's going on? Then once you have that, it's time to actually make the plugin. So there are ways you can leverage Python in Unreal without creating a plugin, but we're doing it this way. There are other ways you can use Python paths as environment variables, but because we are wanting to create a plugin that represents how Unreal actually works, we're just going to take you through creating the plugin, and this is how we did it. So open the plugin panel, you click on Add, then you'll get the plugin menu like you see over here. You basically go content only and you fill out your details of what your plugin is going to be about. Then you click create. That'll create the ueGear is our plugin. So that'll create the plugin at the location that you specified. And then most likely all of this won't be there. You might have source or content, but the rest of this won't be there. Now, what you need to do is you need to create the Python folder under content, and in there you can put your packages. And once that data is in there, then it will reflect correctly in Unreal. Everyone likes to work in an IDE. I mean, there's some people out there who don't like to do that, but I prefer to work in an IDE. And if you like to work in an IDE too, then you need stubs. So stubs or auto-completion, Unreal will generate those for you, but it doesn't do it automatically. What you have to do is you have to go to the editor preference plugins and go Python and then check developer mode. And once you do that, it will generate the stubs for you. But it doesn't do it at that moment in time. So what you have to do is you have to restart Unreal, and then once you've restarted Unreal, the stub file will be there, and then you can import that stub file into your IDE. I recommend that if you are interested in this and auto-completion, do check out the docs, because everyone uses a different IDE, and Unreal, the documentation, have basically laid out how you set up each IDE really nicely. So it's like really just 1, 2, 3, follow the tutorials on the documentation, and Bob's your uncle, and you've got auto-completion. Now, one thing that coming from a Linux background and big productions, that we use mapped folders or symlinks. Now, a lot of people here probably haven't ever heard of that, but what it allows you to do is it allows us to compile our plugin, because the plugins have to be compiled, even though if they're Python. So it compiles it to a location where it'll be used in the engine. Then, because we're using Python, we don't actually need to recompile that. So we can just edit the code directly. But if we will be editing the code directly, you'll be editing the code outside of your Git repository, because your Git repository will most likely be elsewhere, and your plugin will be in your project. So what I did, and what I find is really helpful, is that you create a symlink from your Python folder that's in your plugins to the Python directory that is in your Git repo location. And that allows you to go ahead and code as much as you want. In your Git repo, you commit your code, and then you can just go directly into Unreal, don't have to restart it, and you can just reload the modules, and your code is right there, and you interact with it. You don't have to restart, recompile, none of that. It makes it much faster. Then, time to run some code. So Unreal has many, many ways of running code. I usually just use the command or the Python module way. You can use blueprints, but all the code that we're talking about here is more pipeline code. So it's not evaluated in-game engine code. And the way I like to code with this is that I will do all my coding in a file, and then in the command function, I'll just go command and type the file name and hit enter. That makes it much easier to do iterations, because your code is sitting in an IDE somewhere. You're doing changes, you're just running the command over and over, seeing what happens, and I find that to be quite fast. The other thing that often will happen is that you'll hit a bug. You'll hit a bug somewhere in your code that you cannot debug in your IDE, and you have to debug it at real time in the engine. And that's when switching the drop-down that you'll see over here in the command to Python works wonders. So you switch it to Python, and then you can just import the Python module. You can import your module that you're working on, and then you can just start debugging. You can just create instances and queries and logs and go crazy. So cool, the code isn't done. At that point, right now, you can go ahead and you can code. That's Python. Python, set it up, done. Let's let the adventure begin. Whenever I start working in a new API, whether it's Unreal, some other application, there's usually the hello world for coders. I like to think of it as the DCC hello world for coders. So in case anyone doesn't know, DCC is digital content creation. That's like Maya, Blender, all those applications. And I like to think of the hello world for those as CRUD. Can you create, can you read, can you update, and can you delete? And I usually set out to just try and interact those 4 ways. And then once I have that interaction, I feel more or less confident enough to delve deeper. So lessons that we learned when we dived in. First of all, I come from a linear background, Weta, visual effects, animation, and you think DCC. You think, I have one giant monolithic application, and in that one monolithic application, I'm going to query 1 or 2 modules, and those modules will get me the data that I want, and then I can interact with it. Thinking Unreal, you have to think differently. You have to think, what system do I want to interact with, and what data does that system have? And to turn that around, it's what data do I want, and where do I think that data exists in Unreal? And then you have to query that data. So when you're thinking that way, you have to think, this is Unreal, and these are the systems some of the systems that you have to interact with on an everyday basis. Things like the editor utility library, the assets tools helper library, and through each of these, you'll be able to get the data that you want. I color coordinated them, so it makes it a bit easier. So everything that is in pink is the level. That's how you interact with data that's in your level. So the editor actor subsystem, the editor level library, Unreal editor subsystem. Everything that's blue is basically interacting with content data or in your content browser. We're just going to dive into code, so it's going to get a bit codey now, just to explain a couple of things. So we have here just getting your selected asset data. So you use your editor utility library, and that gets selected asset data. That will return an asset data type, compared to when you say get selected assets, which will return an object data type. And the reason why I want to show both of these is because sometimes when you're interacting with Unreal, it'll ask specifically for objects, and other times it'll ask specifically for asset data. And you can't necessarily always get in Python from the object to the asset data. So sometimes you have to go around to get to that final bit of data that you want to utilize to perform the actual task that you want to do. Getting folders. So getting folders is actually quite straightforward if you're looking for a relative path. So editor utility library, get selected folder paths, boom. That's your folders that you have selected in the content browser. But the problem with that is that that's all relative. And then that you have to basically do a whole bunch of conversion using Unreal paths to get it to be an absolute file path. And the reason why we want absolute file paths is because that's how we're going to be interacting with data in Maya. We're going to be passing absolute file paths from Unreal into Maya, and then basically altering the data that lives at those locations and then passing it back. This also brings up another very important thing regarding Unreal. So in Python, most of you have used sys, your system modules, and then you have sys.path, and you think, oh, I can use sys.path to interact with Unreal. I've had this absolute path, I kind of know where I want to work. Don't. Do not do that. Unreal provides a whole bunch of helpful functions and modules. Like in this regard, it has Unreal paths. And what's happening actually is behind the scenes, even though you think it's doing exactly the same that Python sys.path is doing, it's actually not. In Unreal, it's doing a whole lot of checking redirects, checking the status of those files. So you want to leverage the Unreal system path module, and you don't want to do the Python system path modules. It will catch you out if you're new to Python and you're going along and you're interacting, and it can cause quite a lot of issues because you'll be getting data and it won't be pointing to the correct location. So try and always remember, when interacting with Unreal, always use the Unreal modules and an API. One caveat, you cannot get anything that's in the section. If you go, oh, I want to get the folder, and you in a subfolder, and then on the left-hand side you're like, oh, Bungee Man, I want Bungee Man. So you click on Bungee Man, like I have it highlighted there, and you go, get the selector folder. It's going to return you nothing, because there's nothing in your content browser on the right that's actually been selected. So the left is like your tree, and that's great, but the right is actually the content browser where you're going to be getting the selected data from. Interacting with level data. So actors, getting an actor is a different system than deleting or creating an actor. To get a selected actor, you can see you use the editor actor subsystem, and you just say get selected level actors. Really, really simple, and that will return Unreal actor object. Then if you want to delete an actor, you have to actually use the editor level library. So every level has a library, and then you have to go ahead and destroy the actor that's in that level library, where even creating an actor is even a bit more complicated, because you can't just be like, oh, this is the path to the asset that I want to create. You basically have to provide the path to that asset, which is, you can see source path. And then you have to still load that asset. And then once you've loaded that asset, then you have the asset data that exists at that path location, and then from there you can pass in that asset's data to the editor level library and spawn an actor from an object. And that will finally get you an actor in the level. So this is really great for when we do things like importing assets from, say, we use Kitsu at work, but if you have like a location of an asset that you know, and you have, say, a scene, or you go import the environment, then you can basically go and you can import the environment using this kind of create actor. Getting the viewport matrix. So all of us probably at some point use sequencer, and you can export the camera and import the camera from sequencer and get the camera information. That's really quite straightforward. We'll cover that. But what you can also do is that when you're moving around in the viewport, just doing whatever you want, you can query the viewport by querying the Unreal Editor subsystem and getting the level viewport camera. And that's actually not the camera that is in use. That's the camera that is the actual viewport. And then you can convert that data like we're doing here. So here we basically get the level viewport. We get the location and the rotation because it returns that. And then we basically transform that rotation into a transform. And then we assign the translation into that, and then we convert that transform into a matrix. Yeah, a lot of the data that I've coded is quite mathy. Yours doesn't have to be as mathematical as this, but what I'll do then with the matrix is that I do conversions from left-hand rule to right-hand rule. And there's a whole bunch of that. If you've ever had to work with Maya and Unreal, there's a lot of conversion from left-hand to right-hand space. And those functions are all included in mGear and ueGear, so you can utilize them too if you want. So you have that point now. Yes, crud, got it. Selecting, creating, perfect. Now comes the fun part that everyone has to do. You know, if you ever worked in a DCC and you're working with Unreal, FBX. These days there are other ways, but FBX seems to be the go-to. And we went with FBX for our standards because everyone seems to use FBX in the industry. USD is slowly coming, but it hasn't matured enough, I think, as a addition into Unreal. But yeah, so your standard DCC FBX experience is you export it, import it, and then you validate. And that's kind of like your iteration. Cool, rigging, export it, then someone imports it into Unreal, then you have to validate it. The bones are wrong. Okay, or do it again. And the same for models. Static mesh, you import it. The normals are broken. Iterate. What we set out to do when we were looking at mGear, we were thinking, well, we want to cover static meshes, skeletal meshes, and animation meshes. And each corresponds to a different department, and we wanted to support that department. So we want to make sure that we could handle each of those with FBXs. What I assumed when I started this journey was, Unreal will have an FBX factory of some sort, and I'll just be like FBX factory.path, that's the path I want, import, go, done. No. I was horribly wrong, and after spending a lot of time in Unreal Python's API, there are quite a few ways of importing and exporting FBX data. There are actually about 7 or 8 ways in Unreal. This way I'm going to show you now is the most stock standard way, where you have the ability to do as many alterations to the options. But then later on in Sequencer, we cover another way of importing, because Sequencer has its own way of importing and exporting FBXs. So what you actually need to import an FBX into Unreal is you need these 3 basic classes. You had the asset import task, the FBX import UI, and the asset tool helper. Now, the asset import task, I like to think of it as a way of handling files. And you think of it as, I'm creating a task to handle a file. What's my file's name? Where's my file going? If a file exists where my file is going, what am I doing to that file? I'm going to replace it. If a file was to go there, do I want to bring up a menu for the user to select that? And then once my file is actually in Unreal, what am I going to do? So that's the save. Saving will save the file once it's in Unreal. Automated, if it's true, it means that I don't want to bring up a menu, no UI. And then replace existing is just, replace if something is there already. This one got me. So this is called the FBX importer UI, but there's no UI. And when the first time I had to interact with it, I was like, how do I do this so it doesn't bring up a UI? Yeah, don't worry about that. User interface, I'm guessing they're literally talking about user interface, not a visual user interface. So we create a task like we did in the previous slide, and then we set the options in the task to be the Unreal FBX import UI options. And then that creates ways of us to interact with the different types of data that we want to import. So with regards to that, this here is just showing you just some of the ways you can set up the options for importing an FBX. So we have the mesh type to import. You specify whether you want a static mesh, an animation, or a skeletal mesh. If you are selecting to import animation, you have to make sure that you specify the skeleton to import that animation on, or else you're going to get you will still get an animation, but it won't relate to a skeleton. Things get a bit weird. Yeah, just don't do that. And then once you have the task set up, you have to use the asset tool helper to actually trigger that task and perform the importation. Now, you can see here is that there's asset tasks, so it takes an array of tasks, and then once you fed that array of tasks into it, it'll literally just go and do it. It'll import once that data has been fed into that function. And then what you have to do is you have to query every task for the status of it. Like, has it been completed? Is it finished? The task itself will tell you. So that's great. Now we have the process of importing FBXs and animation and static meshes into Unreal, but we haven't, we still have that iterative process: export, import, verify, validate. We want to speed that up because, yeah, like you saw earlier, one click, it's beautiful. Many clicks, it's not beautiful. So I came across this, and this is my new favorite plugin, the Remote Control API. What the Remote Control API does is it allows you to basically connect to Unreal via a WebSocket, and you can basically pass in any query you want, any data, in or out. It's great. You can drive Unreal basically through this Remote Control API, which, Remote Control API, it's kind of straightforward, but I didn't know that. So you learn something new. To enable it, you basically go to your plugins and you tick activate, and that will activate the Remote Control API. It's pretty much that straightforward. But there's one caveat. You can access everything without C++, but for us using ueGear, we wanted to make it a bit simpler. So we did a little tiny bit of wrapping that lives in our ueGear repository. If you are interested in the code I'm going to show now, just go ahead, go to the ueGear repository, grab that code and utilize it, because it'll make your life so much easier, especially when I start to show off how we structured our data. So in mGear, we have our commands, we have our bridge. So our bridge is basically just a class that handles WebSockets. And then our commands are all our specific commands that we call that then tell Unreal to do a command. So it's like, hello, I'm going to do this, and this, we're listening over there. Okay, I get what you've said. I'm going to perform that. And that is all happening through WebSockets. And how we handle the data so that it looks as if a one-click button does everything and it's all amazing is that you can't send that data through a WebSocket. I mean, technically you could if you wanted to make it very complex. You could convert the data into binaries and send that binary data through a WebSocket, but that's overkill, and it just makes your life more complicated. So what we do is this isosphere that you see here that is in Maya will basically generate a folder in a temp location. We export that using our FBX. If we have any other extra metadata, we'll export it into that same temp folder. And then mGear with the command, it'll just pass a location. It'll say, like, do this command, and this is the location you want to do it. And we pass that to ueGear, and then ueGear, which is in Unreal, will basically go, ha, cool, great. This command, I know what to do, and it'll just import from that temp location, and then it cleans it up. And what you see there is what that demonstration I showed earlier, where one-click imports, one-click exports, updates. Everything there is this three-step process, but it looks like it's one step. So what does a command actually look like? So in Maya, this is our example of a get skeletal data command. You can see here we have bridge.ueGear bridge. That just creates an instance of our WebSocket interface. And then all we do is we call, this is the command I want to call, get skeletal data, and that is the string name of the command that lives in Unreal. I just want to pass in the parameter. This is the skeletal mesh that I want, and then I'll wait for the result. Then in Unreal and the ueGear side, we have get skeletal data, which is the actual function. As you can see here, matches get skeletal data. And that will just perform some queries like, is the skeletal data, has a skeletal data mesh been set to true? If it has been set to true, it'll get the skeletal mesh. If it hasn't, it'll just get the skeleton. Then we find all the skeleton packages that exist and the skeletal names, and we just return a list of it. And just that is what you saw in the first UI, where we had the list of all the skeletal names in Unreal, and then from there you get to pick the skeleton that you want to apply the animation to. So, thinking shots. Let's go sequencer. Over this whole conference, there seems to be more and more interest in sequencer, and I really can understand why. Sequencer is actually extremely powerful. We utilize Open Timeline IO. They have a Python binding, and with that you can basically import all editorial data directly into your sequencer, create shots, and you can basically extend that with your with whatever it is that you want. So interacting with the sequencer came with the same learning curve as importing FBXs. It's a bit daunting at first, but once you know how to use the API, it becomes much easier. So here is hoping I can give you a bunch of tips to get you onto the curve so you can run faster. API terminology. Tracks, that's just like a row. Track is like a normal video editing jargon. In every section that you see, every section, one track can have many sections, and one section can have many sequences. And then also we have subsequences, so you can have a sequence that is built up of sequences. Something to be aware of is that every sequence can have multiple bindings, and a binding is what that sequence will drive. And then we have spawnables and possessables. And exactly as they are, spawnables are actors that the sequencer will make, and possessables are actors that already live in the level. And the reason why I point all those out is because they can catch you out with depending on what you want to do and how you're interacting with the sequencer in Python. So so get current level sequence. This is how you get the current open level sequence. Without having an open level sequence, this will return nothing. So get level sequence editor blueprint library, get current level sequence will return a level sequence that is open. The problem comes is that what happens if my level sequence isn't open? If your level sequence isn't open, then you have to otherwise get the asset data, which is you have to load the level sequence path, or you have to force the level sequencer to be open. And that's what I usually do. I just force it to be open. It pops it up and then shoves in the level sequence that you want. And to do that, you actually go you go Unreal Editor Asset Library, find asset data, and you pass in the location to the level editor level sequencer that you want, and then you get the editor's subsystem, asset editor subsystem. It's not an instance. You basically get the asset editor subsystem that is currently running, and then once you have the asset editor system that is running, you basically tell it to open the editor for assets, and then you pass in the asset. It's kind of a little bit convoluted, but you just wrap that in a module, and it makes it nice and easy. So subsequences. Subsequences can have multiple sequences inside of them, and there are some caveats with interacting with some subsequences that it's good to be aware of. So I'm going to show some of those now. But once you have a sequence, you can basically just get my track, and then you can go track, get sections, and then for every section you can get the sequence that is associated to that section. Get subsequence tracks. Once again, you can find, get all the tracks of the subsequence. This is kind of just how you're interacting with the subsequences and the level sequences. Getting bound objects can be a bit more complicated. The reason for that is that you can have, depending on where the sequence is, you can have different objects bound at a different time. So we had to query a few things that you haven't seen before to leverage that. First of all, we have to get the world. So a lot of people haven't ever heard of world. Some people have. So world is basically like your current level that you're working in. A level can be a world, and one world can be made up of many levels. But to get the correct data out of the level sequencer, you have to know what world you're in. And you can just get the world at a specific time. So what we do here is that we have the level sequence, so we know what the playback range is for where we want that data to be queried from. So we basically query the world, and then we say, hey world, at this time, what is being bound to this sequence? And that will return all the sequence objects. And then we can just return those sequence objects to be performed with whatever you want. So here we go. This is a subsequence. You have your start and end, which is your green and red. And in the subsequence, the clip in the subsequence can also have a start and end. But there are some things to be aware of that might only affect you when you're working with subsequences. Is that a subsequence sequence doesn't have to have a start or an end. So you have to be aware of that, because if you're querying for a start and you're expecting a start to be there, a start might not always be there, and neither might an end. So that can catch you out. I also encountered updating views and work ranges as I was sometimes doing tests with large amounts of shots and wanted to focus in on a shot more specifically. And what I mean by that is that sometimes you are working with 50 shots and you're specifically wanting to focus in on one shot. So you can interact with the view range and the work range, and that'll help focus in on what you're working on. But there are things to be aware of. So when you are interacting with the playback range, you can interact with it quite simply. You can just get the level sequence and you can get the playback range. And the nice thing about that is once you have the playback range, it's in frames. So you have your start frame and your end frame. That's perfect. It's nothing to worry about. It's easy because it's all based on frames. What I've heard from many talks is the subsequence or subframes. And that's when you have issues. And subframes is not something you have to worry about when you're interacting with the playback range. Subframes you have to worry about when you're working with the work ranges, because work ranges are stored in seconds and not in frames. So you can get 0.1 seconds, 0.01 seconds, and it will catch you out. It caught me out. And so the best thing to do with that is that you get the sequences display rate, and it's a numerator, and that's basically your frames per second. And then once you have the sequence, you can get the work range, start and end, which will be in the seconds, and you just basically multiply get your work range start and or end, which is seconds, by your frame rate, and you just round it up. You might have 0.1% of a frame, but if you're rounding everything up and you're querying everything at the same time, what I mean by same time is that you're always using the same application to query your sections, then all the rounding will fit up because one section will be slightly up and one section will be slightly less. So they'll basically align 100% all the way. And we found this to work really nicely when I was interacting with EDLs with editorial. It's because we would ingest an EDL, and before we had figured that little rounding up, we would always end up with some editorial data having a slight slip, whether it's a slip before or a slip after. So rounding it just helps solve that. Then we have sequences again, FBX. So like I was saying earlier, there are many ways to skin an FBX. Importing an FBX camera is a whole different process. You cannot import an FBX camera using the previous FBX importing that I showed. You have to use it via the sequencer. And to do so, basically, you first, the way we've done it here is that we check if a sequencer is possessable or the sequence is spawnable. Then we look for, is that camera track a binding of some sort? Like, does that actually exist? And then we perform the following to actually import it. So to import a camera, you go Unreal, get editor subsystem, you get the Unreal editor subsystem. Once again, you have to find the world. Then you use a movie scene user import FBX settings, which is different to the other FBX import UI settings. Yeah. And then you have to use the sequence tool. So basically what happens is that you tell the sequence tool to import your level sequence FBX, and you get to configure how that data is imported using set editor properties. And set editor properties also makes it nice and easy to interact with attributes and properties that you'll find keyable along your timeline in Sequencer. You can basically just query like a frame range at a time and use the set or get editor property, and that'll add the FBX data into it. So what's next? So currently we're working on control rig. So our version of ueGear for mGear to ueGear, that's basically we're going to be focusing on 5.2, 5.3 plus. So once when we finish and we release it to the public, I say release to the public, at any time now you can go get our branches that we're developing on and start picking stuff around. But the final, once it's actually released and merged into master, you'll be able to use it from 5.2 and 5.3. And that'll be a conversion from an mGear rig into a control gear, or a control rig in Unreal using mGear. And that's hopefully all going to be coming by the end of this year. So yeah, all the code that you saw today was snippets from our repositories that we have. Everything's available. We have master branches, we have developer branches that we're actively working on. Your code is there and free to get. You go and help yourself, access it, pull out what you want, what you don't like. GitHub mgear.dev. And yeah, thank you guys for coming.